Hi, this is Dr. Dave. Let's take a look at a problem from section 13.3, which is about conditional probability. A container contains 35 green tokens, 20 blue tokens, and 2 red tokens. 2 tokens are randomly selected without replacement. Compute the probability of F given E, where E is you select a green token first, and F is the second token is non-green. So the first thing I'm going to notice about this is that if I add together the number of tokens here, we get 35 plus 20 plus 2, or 57 total tokens. So the way we're going to solve this is we're going to go ahead and draw a tree diagram. So we're going to think about what happens when we draw the first token. You could get a green, or you could get something that's not green. So I'm going to write down the green token as being E, and not getting a green token as the complement of E. Now once I've gone ahead and gotten the green token, I could get a green token again, or I could get a non-green token. So the second token is non-green, would be F, and then the complement of that would be the green one. And I could have the same thing down here if I had drawn a non-green token first. So I'm going to go back to thinking about drawing that very first token. Remember, there are 57 tokens total, and of those 35 are green. So the likelihood that you would select a green token first is going to end up being 35 out of 57. That means the likelihood of getting a non-green token is going to be 22 out of 57. So I'm counting the green tokens on the upper branch and the non-green tokens on the lower branch. Now for the next stage, I've already drawn out a token, and I have not replaced it because that was one of the key things here. It said without replacement. So what that tells me now is when I go ahead and draw that second token, I'm always going to be dividing by 56. And it doesn't matter which branch I'm on, it's always going to be dividing by 56. So I'm going to go ahead and label that in each one of these. If I drew a green token first, so I'm on the upper branch to get to E, the likelihood of getting another green one is going to be 34 out of 56, because remember, I've already drawn out a green token, so there's one less token than there was before. Now since the first one was green, the likelihood of getting a non-green, so that black branch there, so there are 22 non-green, so I can go ahead and label that. And notice that the total number along these two branches is 34 green, 22 non-green. That's what determines the probabilities. Now let's go down and look at the lower branch. Remember, this was where we got a non-green. Now the likelihood of getting a green one, since the first one was not green, there are still 35 green ones left. Now if I had gotten a non-green, that reduces the number of non-green by 1. That means there's 21 left that are non-green. So now that I have everything labeled here, I can go ahead and think about exactly what I'm trying to find. Remember, they asked me to find the probability of F given E. So the given E is that you select a green token first, and then the second part of that is that the second token is non-green. So I need to locate that here along these branches. So when it says given E, that means I must be along the upper branch. So that would be the branch right here. And then when it says probability of F given E, that's just the section that I see right here. And I've got that labeled right here. The probability is 22 out of 56, so that's the answer to this problem. Given that I had a green one first, that means now there's only 56 tokens left. I want the likelihood that the second token is non-green. That means there are 22 non-greens left. That's what forms the probability, 22 out of 56.